For this podcast, we're going to learn how to prepare solutions when we have known molarities and volumes and a molarity or a volume that we're trying to get to for a substance. All right, so we do have to review molarity just briefly because when we talk about solutions and concentration, molarity is the obvious unit. So molarity, as you remember, is the moles of solute per liter of solution. So we use the equation capital M for molarity, moles divided by liters gives us the concentration or the molarity for our solution. So just as a very, very quick reminder, and you feel free to fast forward me if you don't need this reminder, what mass is needed to make 2 liters of a 1.5 molar sodium carbonate solution? So we know that we are starting with 2.0 liters of solution. Okay, so we're going to go from liters to moles, and to do this, we're going to need molarity, and then we're going to go from moles to grams. And to go from moles to grams, we're going to need the molar mass. So sit tight for a second. So to go from liters to moles, we're going to use the concentration. So I know that I have 1.5 moles per liter. That is the molarity given here, moles per liter. I can cancel liters and I'm left with moles. The final step in going from moles to grams is to take the molar mass. So I'm going to add together the mass off the periodic table for 2 sodiums, 1 carbon, and 3 oxygens. To save us time, I'm going to go ahead and just write that up here. All right, so adding all that up together, we get 105.99 grams per mole, and I'm going to put in the substance of sodium carbonate. And when I add this all up together and put it into the calculator, I get 317.97 grams, and I'm going to need to round this to 3 sig figs. I forgot the 0 on there. 3 sig figs, so this should be 318 grams are needed. So quick primer and reminder of how to do molarity. So to prepare a solution, we go to the stockroom. The solutions that you have are concentrated. They're cheaper to ship. They're more useful. Nobody ever wants to use a super strong molar acid or base, so dilution is the name of the game. We can add water to make it less concentrated, to make it a safer molarity to work with. So dilution is the addition of a solvent, in this case it's usually water, to decrease the concentration. So the amount of solute is constant and only the volume of the solution changes by adding solvent. So our equation to do this is M1 times V1 is equal to M2 times V2. These are molarities and volumes. The nice part about this equation is that you don't have to convert the volumes to liters. You can work with milliliters as long as the initial and the final are reported in the same unit. You don't have to convert. So let's look at our problem. How many milliliters of a 10 molar solution, that's our M1, would be needed to prepare 600 milliliters, V2, of a 2.00, we're going to put a decimal right there, molar solution. So it looks like this is V1 that we're looking for. So let's set up our equation. M1 V1 is equal to M2 V2. We are solving for V1, so I'm going to divide both sides by M1. Okay, so let's go ahead and plug in some numbers. M2 is 2.00 molar times V2, which is 600 with a decimal milliliters, divided by my initial molarity, which is 10.0 molar. So that's a pretty strong, pretty concentrated molarity. I wouldn't want to work with that, depending on what the solution is. I guess if it's vinegar, I wouldn't care. Acetic acid, no big deal. Hydrochloric acid, no thank you. We'll plug this into our calculator and we'll round to 3 sig figs because that is the least in the problem. And we get 120 with a decimal milliliters. And I include that decimal because I want to have 3 significant figures. So what this is essentially saying is I need 120 milliliters of a 10.0 molar solution to start. Okay, to start. I am then going to add water until the final volume is equal to 600. When I add water to 600, I can expect the molarity to be 2.00. So it tells us what to start with and then what our final volume is going to be. So this is what it would look like in lab. We start with our stock solution. We measure a desired amount of solute out. We put it into our flask. So we make sure we have that in our flask, and we have to start with a certain amount of that. That's our V1. And then whatever our V2 is, we're going to add water until we reach that measurement, that 600 milliliters from the last one. And we know the solution in there will have the molarity that we desired, as long as we started with the correct volume for the molarity we were given. Okay, so you're literally just adding water to dilute. Depending on your lifestyle, you see a lot of this in your everyday life. Dilution or solution preparation happens all the time. The one I think about the most is when we make orange juice from frozen cans. So that frozen can is orange juice concentrate. And depending on how you like your orange juice, you can add a certain number of water until you get it to the right concentration. If you like yours a little bit stronger in flavor, you add less water. If you want it to be a little less strong, you add more water. We also see this with cleaners that are sold in bulk. They'll sell you a concentrated solution. You just get your own container and add water at home. We see this for Murphy's oil soap and all-purpose cleaners. So we see a lot of concentrates in our everyday life.